This thin pouch powers your phone from morning to midnight. Inside are layered electrodes, a separator, and a reactive electrolyte. Every swipe, every call, every photo runs on stored chemical energy. Billions of these cells ship every year from a handful of factories. One of the largest sits here, where chemistry becomes portable power. Today, we follow how a phone battery is built from raw chemistry to sealed cell. At this scale, a few micrometers of coating decide how the battery behaves.
She watches thickness and moisture because both change cell performance. Inside the dry room, moisture is the enemy, and everything is built to keep it out.
A phone battery begins far from a factory, where lithium is pulled from the ground. And one batch of electrode material begins its path toward a working battery. That raw mineral is refined into battery-grade lithium compounds. The cathode material is synthesized separately under high heat and strict chemistry. The anode side starts with graphite, purified and shaped for layered storage. Between them goes a separator, a thin membrane that allows ions through but blocks electrons. Then come the current collectors, thin aluminum and copper foils that carry charge in and out. The pouch itself is a laminated film that seals and protects the chemistry inside. Nothing enters production until chemistry and dimensions are verified. Only after testing does any material reach the production line. First, cathode materials are mixed into a uniform slurry. The anode slurry is prepared separately with the same precision. Then the cathode slurry is coated onto aluminum foil in a controlled layer. Thickness is measured continuously because variation changes capacity. Drying removes solvent and leaves a solid electrode layer on the foil. The anode is coated onto copper foil using the same process. After drying, both electrodes look simple but carry exact chemistry inside. Next, heavy rollers compress the cathode to a precise density. The anode goes through the same compression step. Compression controls how ions move and how much energy the cell stores. Then the wide rolls are slit into strips sized for phone-sized cells. Every edge is inspected because a damaged edge can cause a short inside the cell. Before assembly, the electrodes are dried again to remove every trace of moisture. From here, everything happens in air drier than any desert on Earth. Now cathode, separator, and anode are layered into the cell structure. Each layer must align exactly, or capacity drops,
and risk rises.
The pouch is shaped from laminated film to fit the electrode stack exactly. Then the electrode tabs are welded into terminal connections. The stack goes into the pouch with almost no room to spare.
Two sides are sealed, leaving one opening for the next critical step.
Then electrolyte is injected, filling every gap between the layers. Vacuum helps the electrolyte reach every pore inside the cell.
Then the final edge is sealed, locking the chemistry inside permanently.
Now comes the first charge, which forms a protective layer inside the cell. That layer determines how the battery ages and how safely it operates.
Gas produced during formation is removed, and the cell is sealed again. Then every cell sits for days while voltage is monitored for stability. A cell whose voltage drifts during aging is rejected before it reaches a phone. Every cell is tested for capacity, resistance, and leakage before shipping. Then the outside is checked for seal quality, swelling, and correct dimensions. Cells are sorted into matching grades, so every phone gets consistent performance. A protection circuit is added to guard against overcharge, over-discharge, and shorts. From raw chemistry to sealed power pack, the battery is ready to ship.
But the cells shipping today were designed years before they reached this floor.
Inside, engineers push cells to failure to understand where limits exist. For Dr. Zhao, the question is always the same: more energy without less safety.
Every generation has to store more energy in the same space.
The separator decides what passes through and what stays apart.
The internal resistance is spiking. Check the thermocouple readings at point 4. Noted. The temperature is holding steady.
That is why every new design faces deliberate abuse before production.
Most of that work stays hidden until the next battery generation ships.
Inside battery manufacturing, moisture is the most persistent enemy.
Even trace moisture reacts with the electrolyte and damages the cell from inside.
That is why assembly happens in air drier than any natural environment.
Even small coating variation changes how the cell charges and ages.
When thickness drifts, the coater is adjusted before the batch continues.
A metal particle inside the cell can pierce the separator and create a short.
So every step is designed to prevent particles from reaching the cell.
During first charge, the protective layer must form evenly across the whole anode.
If it does not form right, aging catches the difference before the customer does.
A stable battery line is not luck. It is constant adjustment.
What fits in your pocket is manufactured here by the millions. These cells power smartphones used by billions of people every day. Smaller versions run the wearables people carry without thinking.
In medical and connected devices, battery reliability becomes critical.
That is why a part this thin carries so much responsibility.
She trusts the raw data before she trusts the meeting summary.
A reference cell helps prove the process is still producing to standard.
On this floor, even a small moisture reading is treated seriously.
Veteran engineers remember when half this capacity filled twice the space.
At home, her daughter only knows one thing: the battery made it through the day.
For Yuna, that means the chemistry held.
From raw lithium to sealed cell, that is how phone batteries are made.
What surprised you most about the process? Tell us below.
Next, we enter another factory, where invisible precision powers everyday life.
Process Pulse Factory. Subscribe for the next process.